Okay, I think we can start the session now. So is my screen is visible?
Yes, it is.
So we'll start the session with the week 7 content, then week 8, and then week 9. Okay. So what are the content it has covered in the lecture? So that we are going to discuss first, and then one example based on each concept. Okay. That's how we'll proceed. Yeah. So in the lecture 7.1, we have discussed about the function of one variable, that is trigonometric function. Okay. So when I talk about first function, that is of sin x. Okay. So can you tell me what is the domain and the range of this particular function sin x? Hello. Just tell me the domain and the range of this particular function sin x. Am I audible, right? I'm audible, right?
Yes.
The domain R and range -1 to 1.
-1.
Yeah. So domain R, that is, I can take the values from -infinity to infinity, and the range is from -1 to 1, right? So whether this sin x is a even function or odd function, how to check?
We can check sine of -x.
Yeah.
Is it minus sine x?
Yeah. If f of minus x is giving me f of x, then I can say my function is even function, right? F of minus x is giving me minus f of x, then I can say my function is odd function. So if I replace x by minus x in the sign, what I will get? Minus sine of x, right? So basically it is a odd function. Okay. If I plot the graph of sine x, it will be like this. Okay. So it will keep repeating the periodic interval 2 pi, right? So sin x, it is a bounded function, right? Its upper bound is 1 and lower bound is -1, right? Similarly, you can say for cos x also, right? What is the domain of cos x? Same, right? Minus infinity to infinity.
Real.
Yeah. Range is -1 to 1. Whether it's odd function or even function? Cos
It's
x?
Even.
even function.
Even function, yeah. There is bounded or unbounded function?
Bounded.
Yeah, it is a bounded function, right? Now, third trigonometric function is tan of x. So what is the domain of tan of x? Just anyone? And the range?
Our domain is the whole real line, minus infinity into infinity.
Domain is
Except 0. Except 0.
except 0.
R minus and pi by 2.
Yeah. Sorry. So this is my x-axis. This is my y-axis. So graph will look like here. It will be minus pi by 2. Will be pi by 2. So for the odd multiples of pi by 2, this function will be not defined, right? So I can say that r is basically r minus twice n plus 1, that is pi by 2. This odd multiples of pi by 2, right? Yeah. And this range is minus infinity to infinity. Okay. So now tell me whether it's even function or odd function?
Odd.
Odd function, right? Because minus tan of x will give me minus tan of x, right? So x tan of minus x will give me minus tan of x. So basically it is an odd function. This is bounded or unbounded function?
Unbounded.
Unbounded function, yeah, right. So it is an unbounded function. I think this is clear to you, right? Sin x, cos x, and tan x. So please note this point, like what are the odd function and even functions, okay? So now in the week 7, we discuss about the arithmetic operations on the function, right? So if I given say f of x, say anything like x cubed plus 6x squared plus say 7, and I have g of x, so I have x squared plus x plus 8. So when we do the sum of f of x plus g of x, we add the coefficient of the term having the same degree, right? So here that is x cube only. So 6 plus 1, it's the 1, that is 7x squared. So here 0 plus x, that is x, plus 8 plus 7, that is 15. Okay. Similar in the case of minus also, right? Plus and minus. Now what is product function? If I want to take the product of f of x into g of x, so what I have to do? I have to multiply by x cube to the whole function, then plus 6x squared into the whole function, plus 7 into the whole function, right? So this is the product function f of g, this one, right? So c, yeah. So c is a constant function. So c of x, you can write it like this. And also for a quotient, f of x equals to g of x, right? But in the week 3 and 4, you have learned these things, right? Yeah. So this is basically arithmetic operations on functions. You can go through it like. Now the main part of the week is basically a composite function. Okay. So yes, you can tell me what is composite function?
It's a combination of functions. So the thing is, if you have a function f o g of x, the domain of the range of g of x is g of x, and the domain of f of x is g of x.
The domain of g of x.
So if it's f over g of x, so you can draw three sets: x, g, g of x, and f of x.
Okay, let's say for example, I have a function f of x equals to say x square, and g of x equals to the under root of x. Okay, so what will have fog? Fog means f of g of x. Yes, and what is fog? That is g of f of x. Anyone? I have to simply put instead of x, g of x. That is g of x square, right? Yes, anyone? Root x square, that is x only, right? And what is my graph here?
Square root of x squared.
Sorry, square root of,
Square root of x square.
yeah, that is x only, right?
Yeah.
Now suppose I want to find out the domain of this fog. How to find out? So there are basically three steps. First is you have to find out the domain of g. Okay, domain of g of x. I'm talking about fog only, right? Then this domain of g of x, right? It will become the range of g of x will become the input for the f of x, right?
What
Yeah.
happened?
No, I was thinking if that's switching back.
Hello. Yeah, please mute yourself. Yeah. Now in the step 2, you have to find out the range of g of x. So basically this range of g of x will become the input for f of x, right? Then we have to find out the domain for f of x, right? So domain of f of x. Then we have to check certain two conditions. Okay. So anyone know that how to find out the domain of any this composite function?
So we can go one step at a time. First, we'll see what is the domain of g of x. So since the function is square root of x, it can only take values from 0 to infinity. G of x, the function g has a range from the whole real range and a domain from 0 to infinity.
Yeah. So now I'm asking about the say, suppose there are two cases, right? If range of say g of x is a subset of domain of f, right? Then domain of fog will be fog of x will be is equal to domain of g of x, right? Domain of g of x. Okay, let me take one different example. We can try out it. Okay. So be my function be f of x equals to g, right? Of x. It's visible, right? What I am writing in the red color function. Let's say f of x is 1 upon 1 x plus 3 and g of x is say x square plus 4. Okay. Now I want to find out the domain of g. What is the domain? Okay. So first fog of. So now I want to find out the fog of x. So domain of this particular function. Okay. So just apply this 4 step. First find out the domain of g. So what is the domain of g here? Domain of g of x. Yes, anyone? What's the domain of g of x?
Minus 2, 2.
Minus r minus. Yes.
Sir, R, only R.
Only r. It can take all the values, right?
Yes, sir.
Okay. Now what is range of g of x?
To infinity.
Yeah. So range of g of x will be sorry, it cannot take negative value, right? So 0 to infinity, right?
It will be 2 to infinity.
2 to infinity, right? If I put minus 2 here. Oh, sorry.
No, because x can
Yeah,
only
2 to infinity. Yeah, right.
because x square can only be 0 onwards, right?
Right. 2 to infinity. Okay. So now what is my domain of third step is domain of f of x. So what is domain of f of x?
Everything except for minus 3.
Yeah, so this function is not defined at x equals to 3, right? So domain of f of x will be r minus 3, right?
Yes.
Yeah. So now see, check this condition whether this my range of g of x subset of domain of f. Is this satisfying? So my range of g of x is 2
So
infinity.
is it 3 or minus 3?
Oh, minus 3, sorry.
Minus 3.
Yeah, minus 3. So let us check this condition. Whether this my range of g of x is a subset of domain of f or not.
Yes, yes.
So r minus of 3, right? So only minus 3 is not there, but it is subset of this basically r minus of 3, right?
Yeah.
Yeah. So in that case, my domain of fog will be what is the domain of g, right?
Yes.
Domain of g will be r, right? Is that okay? Hello?
Yes, sir.
Yes, sir.
Yeah. So there's one more condition, like what if this condition is not satisfied? This is case 2. Yes, anyone in that case, what will happen? So this is basically case 1, right? So what if this condition is not satisfying? So suppose if range of g of x is not a subset of domain of f, then in that case, what will be the domain of fog? Yes, anyone?
It will be, the domain will only be there for those values of g of x which are also in the domain.
Yeah. So basically, we have to eliminate the domain of G for which, like, that range of G will be not defined. Especially function is not defined, right?
Yeah.
Okay. Any doubt in this part? Yes, anyone?
Can you give us an example?
Example. Okay. Let us take this example only. Say f of x equals to 1 upon x minus 3. Okay, x plus x minus 3. So this is not defined at x equals to 3, right? And my g
Yeah.
of x will be x square plus 4. So what will be domain? Okay, so here we have to find out. Okay, so domain of f. The first is domain of G. So what is domain of G here?
0 to infinity.
Yeah, domain of G is basically, no, range of G is basically R, right? Domain is 2 to infinity. Hello?
Yes. 2 to infinity.
Isn't it inverse?
Other way around.
Yes. Hello?
So
Ah,
domain will be R and range will be 2 to infinity.
Yes, sir.
and domain is R, no? What I have read? Oh, sorry. This is range. So this is range. This is domain will be R, right? Now, what is the domain of f of x here?
Everything except for 3.
R minus 3
The domain for f of x will be R
minus
except
3.
3. Except 3. This I have changed the function, right? Hello? Here you can say I have changed the function, right?
Yes, sir.
So in that case, whether this condition is satisfying, range of g of x is still a subset of R, right? No, right? No, here this condition is not satisfying. You can see because 3 will be a part of this particular range, right? So this condition is not satisfying. So in that case, what will the domain of this fog then? This case only, like I have considered f of x and this is g of x.
We need to eliminate all values of g of x for which the value comes to 3.
For which the value comes to 3. So
Yeah.
just tell me, so what will be the domain then? R so to infinity minus R, right? So here the fourth will be domain of g of x. So domain of g of x is R minus 3, right? Domain R minus of 3. Right? So this will be the my domain for this fog, for this particular f of x and g of x. Okay? Because we have to eliminate those value for which this function is not defined, f of x, right? Any doubt in this part?
So we can write f of g of x as 1 upon
Yes.
1 upon g of x minus 3.
F of x as 1 upon
F of g of x as 1 upon
x square
square
plus
root
4 minus 3, right?
minus 3. So we need to take all values of x out for which the
Yeah.
x square plus
This is
4.
not defined.
Yeah.
So that will be x square plus 4 equals to 3, right?
Yeah. So
Yeah.
you get x square, x is equal to plus or minus 5.
Sorry, noise is coming. Yeah, please mute yourself. Yeah, okay, tell me now.
You get x equal to plus or minus 5,
X equals to
plus or minus 5, because it becomes x square plus 4 is equal to 9. So
So-
plus is the square root of 5, sure.
yes. For this also it is not defined, this particular graph, right?
Yeah.
Yeah. So we have to remove this also, right?
Yes, so x is equal to plus or minus square root of 5.
Square plus 4 equals to 3, right? So it will be x square plus 4 equals to 9. So x square will be
5.
5. So x equals to plus or minus 5,
Yes.
root 5,
Yes.
right? Yeah. So I have to eliminate this particular 5 also, right? So range will be minus 3 plus or minus root of 5. So this is not defined for this function graph. Okay. Okay. Yeah, Ranjani, can you please mute? Yeah, noise is coming. Okay. Okay, so this will take later. So now next is what is the limit of sequence? Okay. So let's say a and b any sequence of real number, and we can say that a n has limit a belongs to R if n increases. So basically we have to find out, if we want to find out the limit of any sequence, what we have to do, we have to consider limit n tends to infinity, because as the n increases, then what will be the what my an will tends to. Okay, so that basically is sequences. Okay, so like there are other terminologies also, like an tends to an converges to a, right? Say suppose I take one example, say limit of 1 by n as n tends to infinity. So as I'm increasing the value of n, so basically this 1 by n will tends to 0, right? So if I evaluate this limit, I will get 0, right? So it is basically a limit of sequence. Just remember one thing, whenever you have to find out this limit of sequence, just consider limit n tends to infinity. Okay, so an converges to a. So yeah, so suppose if I'm getting,
Sir, in above question, f of g is valid for x equal to 3. So why are we are in the answer, why we are including 3?
it is not a subset of x, right? F of x is valid for, no, we are calculating the domain for fog, f of g of x, not for f of x.
F of g of f, it is valid for 3.
No, this is f x minus 3 now. This particular function is not defined at x equals to 3, right?
Yes. But f of g of x, it is valid for x equal to 3.
Yeah, it will give, but
So in the answer r minus curly bracket minus 3 and plus minus root over 5, we can remove 3, because at root 5, x equal to root 5, that g of x is equal to 3. So that 3 is already removed.
No. So you're talking about graph only, na? Fog.
Yes, fog.
See, basically, this condition is not satisfying, right? Range of g of x is not a subset of domain of f, right? So this basically range will be taken as the input of for this particular function f of x, right? Hello.
Yes.
Yeah. So this function is not defined at x equals to minus 3. Sorry, not this function. This function is not defined at x equals to 3. So if the value of this g of x is coming 3, then in that case, this f of x will be not defined. Na? So suppose here x equals to, if I want to make this as 9, so x equals to root 5, right? So I will get 5 plus 4 under root of 9, that is 3, right? So now this 3 will be taken as input for this particular function, but this my function is not defined at x equals to 3, na?
But f FOG is different from f
okay,
of
okay.
x. F of
Okay.
FOG is different from f.
Yeah, right. So we have to calculate those, eliminate. Yeah, right. It will
We
be
can
plus
remove
minus
3.
5 only. Yeah, right. Because if we take this range as an input for this particular function f of x at x equal to root 5, we'll get 3, but it is not defined for this particular function. Yeah, right. Right. Yeah. Okay. So let's talk about this limit of sequences. Yeah. So when I can say this basically converges to a, say suppose I'm finding out the limit of any function, say any sequence, say an, and n tends to infinity. And if I'm getting any particular value, say anything a, so I can say this limit this sequence an converges to particular a. Okay. So if I'm getting any values, say L or A, so I can say this converges to A. And if limit of an tends to infinity does not exist, or infinity or minus infinity, then I can say this sequence basically diverges, right? Okay. So just you have to find out this limit n tends to infinity for this particular sequence an. And this are other terminologies. You can go through it. Yeah. So let us take few example based on this. So here given to consider sequence an given by an equals to n to the power 1 by n, which converges to is known to converge to 1. So what is the meaning of this? So if I take the limit 1 by n, and n tends to infinity, it will give me 1, right? It will converges to 1, right? So this is given to me. This is 1, right? Now what I have to find out? I have to find out the limit of sequence for bn. Okay. So how to do that? Yes, anyone? So limit
5.
to infinity bn. Yes, what will be the answer? You can directly put the values, right? Hello? Yes, go ahead, please. I can transfer this limit to individual term, right?
Yes.
5 is constant, I can take outside. 5 limit n1 by n tends to infinity, minus this will be 1 only, limit n tends to infinity 1. Okay. So now this is given to me. Okay, so this is given to me. So this is my 1. It will converge to 1. So it is 1 plus 5 to 1 minus 1, right? So basically the answer will be 5, right? Any doubt in this problem? No?
No, sir.
Yeah, this is given to me, right? Okay, this means like limit n tends to infinity for this function 1. Now let us check for the let us go for third question. So here the an the sequence defined as this one. Okay. So what will the limit of sequence bn defined by this particular function? So what we have to calculate? First we have to calculate the sequence for this an, and then same apply this for bn as we have done for the previous question. The same way you have to take the limit n tends to infinity here. So what will be the limit n tends to infinity here? An. Does anyone how to solve this?
Divide
N by
numerator and
50.
denominator
Yeah.
by n square.
Yeah, n square. Why n square only? N only, na?
N only. N
Numerator,
only.
yeah. If I take n common, so what I will get 34 by 7 by n upon 15 plus 10 by n. Okay. So now if a limit n tends to infinity, not equal to that. So limit n tends to infinity 34 plus 7 by n plus 115 plus 10 by n. Now if I put n infinity here, it will be 0 and 0, right? So it will be 34 upon 15. So this will tends to 34 upon 15, right? Now what we have to find out? We have to find out the limit of sequence for a Bn now. Now same thing we have to apply, right? So that is limit n tends to infinity Bn. Okay, so that is limit n tends to infinity 3375 a square n plus 225 an plus 7n square upon n cube plus 1. Yeah, tell me how to solve this limit. Yes, anyone? I can take this constant outside, right? So what is limit n tends to infinity an square or a square? Anyone? What will the value of this?
34 by 15 का whole square.
Whole square, okay. Plus 225 limit n tends to infinity an plus limit n tends to infinity 7n square upon n cube plus n, right? So from here I will get direct value from this particular sequence. So that is 3375 into 34 by 15 ka square plus 225 into 34 by 15 plus. So what I have to take the common from this numerator and denominator? N square, right? N cube. Right?
Yes, sir. Yes, sir.
If I take n cube common, so what will be the remaining? N 1 plus 1 by n cube, right? N cube or n square?
So if you take n cube, so it will be 7 by n.
Yeah, 7 by n, right? Yeah, 7 by n, right? So we cannot do like this, right? So 7 by n we have to take, and okay, no, it's same thing now. I have just mentioned it here. So you have to take the from the numerator highest power, that is x square. So if I take n square, what you will get? N square outside, n plus 1 by n square, right? Here n square. So n square will get cancelled, right? Naresh, can you please mute yourself? So limit n tends to infinity, right? So this will get cancelled. If I put n infinity, it will become 0, right? And if I put n here, that is infinity. That is 7 by infinity. So basically 0 only. So this whole limit tends to 0. So what I remaining is 3375 to 34 upon 15 ka square plus 2 to find 34 into 15 ka square. Okay. So you can calculate that. Whatever the answer comes, you can mention. Okay. So any doubt in this part? Anyone? Just remember one thing. Whenever you have to calculate the limit of sequence, just take the limit and tends to infinity. Okay. That's it. Yeah. For any function. Now here, convergent or divergent sequence. So sequence n is called divergent if it converges to some limit. So that's what I explained earlier. If I am getting any particular answer, say limit n an and tends to infinity, I am getting L any value. So basically this limit will convergent, right? Particular function, that is a particular limit. And if the sequence is called divergent, if it is not convergent. So if I am getting the limit tends to infinity an as does not exist, or infinity by infinity, sorry, infinity or minus infinity. So I can say this sequence is divergent. Yeah. So now what is subsequence here? The subsequence of a sequence is a new sequence formed by the excluding some entries of a sequence, but that is in a particular order. Okay. So particular order. So here I have just removed -1 from all the from the given sequence, and I have formed the subsequence. That is a subsequence of a sequence. It is simple just by through definition you can get it, right? Any doubt in this part? What is subsequence?
Sir,
Okay. Yes.
sir, we are only talking about convergent and divergent sequence, and oscillatory sequence. We have included them in the divergent sequence.
Sorry, which one?
Sir,
Convergent and
oscillatory
divergent. Hello?
Sir, minus 1 raised to the power n is just minus 1, 1, minus 1, minus 1, minus 1, 1. So it is not diverging to infinity and minus infinity. So I was asking,
So this one, minus 1 to the power infinity.
no, sir, no, sir, not that, not that.
Okay.
Okay, sir.
Your
Sir,
voice,
clear.
your audio is not. Hello? Yeah.
Sir, my doubt is clear.
Piyush, can you hear me?
Hello? Yes.
Yeah, see, Piyush, see, the study material which was given was actually videos, mathematics for data science 1, statistics for data science 1. So do we also have mathematics for data science 2 and statistics for data science 2 in the syllabus?
No, not in the syllabus.
Is it there for the exam?
No. It is only for Maths 1. Whatever you are going to cover in the Maths 1, that is only.
Okay, great. Thank you so much.
We have one more revision session. Maybe I think.
Okay. No, because these limits and all is getting covered in that, no? So that's why I was asking.
That is the Maths 1 only. This part particular content.
Acha, it's Maths 1, right? Okay.
Means 7, 8, and 9.
Okay. All right.
Yeah, so please mute yourself. Now there are some useful rules regarding the convergence of sequence. You can just go through it, okay? Nothing in it. Yeah. So now we'll study about the limits. Okay. So what if I say limit x tends to a f of x? What does this limit mean? So suppose this is my axis, this is x-axis, and this is my f of x. Okay. This is my point A. So limit x tends to a f of x means as I'm approaching this particular value a, so what will my function will tend to? What will my function f of x will reach that particular value?
It will tend to f of a.
Yeah. So this is continuous function. We can say it is f of a.
Yeah.
So what if it is not continuous? So, okay, I will take one example also. So yeah. So basically, this limit means if I am approaching this particular value a, so what will my function will tends to? Okay, but I can approach this particular a in two ways. That is from left hand side. That is from right hand side also, right? So if I am getting left hand limit equals right hand limit, then I can say this my particular limit exists. Okay. So say I take one function, say f of x equals to x square minus 9 on x minus 3. Okay. So this function is not defined at x equals to 3. Okay. It's not defined at x equals to 3. But if I want to take limit x tends to 3, I can write this x square minus 9 as x square minus 3 ka square, right? X minus 3. That is x plus 3, x minus 3. And this one is x minus 3. So x minus 3, x minus 3 will get cancelled and limit 3. I can simply put 3 here, that is 6. So even if my function, this function f of x is not defined at x equals to 3, but still that particular value will reach to the this 6, right? Hello, are you getting what I'm saying? Even if my function f of x is not defined at x equals to 3, but we are not calculating the value of f of 3 here, right? F of 3 will be 0 by 0 here. It's not equals to this. I'm just finding out the value when my x will approach to 3. What will the value of this particular function? It is basically 6. right?
Yeah, that is if it's approaching from the right hand side.
Yeah, you can take right hand limit, left hand limit, you will get the same thing here, 6.
Okay, correct.
Yeah, okay. Okay, so yeah, one more concept is there, like, okay, so I can approach this particular point from two sides, right? So what if my this function is not defined at any particular point, say 3 here. So it is, I'm breaking this graph here, 0, okay. So this function is this 3, right? It is not defined at x equals to 3, but it is defined just before that and after that, right? At a distance h, if I take h at a distance h, and here from this side also at a distance h, so my left hand limit, what will be the left hand limit? So limit h tends to 0 is f of this particular a minus h, right? Hello.
Yes.
Yeah. Now here if I want to check left hand limit, what I will do, limit h tends to 0 f of a minus h, because I'm going from left hand side, so this will be a, this will be considered a minus h, right? A minus h, and if I this h will tends to 0, then only my this whole term will tends to a, right? If my h tends to 0, then only my this whole term will tends to a. So that's what we are doing, like limit h tends to 0 f of a minus h. So right hand limit, what we have to do, limit h tends to 0 f of a plus h, right? So yeah, so let us take one example here. So suppose f of x is 1 by x, okay. So now limit x tends to 0 1 by x, is it defined or not at particular point 0?
No.
I have to check the left hand side limit, right? So that is limit x h tends to 0. So f of 0 will be 0 minus h. So that will be 1 upon minus h, right? So if I put limit h equals to 0, I will get minus infinity. From right hand limit, what I will get, limit h tends to 0 f of a plus h, that will be 0 plus h, right? That is plus h. So if I put h equals to 0, I will get plus infinity. So this left hand limit is not equal to right hand limit. So I can say this particular limit does not exist, right? So just check, if you want to find out whether this limit exists or not, just consider left hand side limit and right hand side limit, okay? If it is equal, then we can say the limit exists, okay? It is not equal to f of a. Remember that it is not equals to f of a. Any doubt in this part? We can take few questions. Yeah, so let us check for the first option. So how to calculate this limit? If I put x equals to minus 1 here, what I will get? This 1 plus 7 plus 6 minus 7, right? Here 1 minus 3 plus 2. So basically it is 0 by 0 form, right? So as of now, we don't know the derivative, so we'll not go to air hospital. We simply try to factorize it, right? So what is the factor of this? X minus 7 x plus 1, right? And here x plus 1 x plus 2, right? So this x plus 1 get cancelled. So what I will get, limit x tends to minus 1 x minus 7 upon x plus 2. So it will give minus 1 minus 7 minus 1 plus 2. So it is minus 8 by 1. So, this option is correct. Same you have to do for all the options. Okay. So similarly, you can factorize, like what is the factor for this? This x minus 7 x plus 1 here Same, okay, same is there, right? So that is x plus 1, x plus 2. Okay, first directly put the value 0. Whether this limit is indeterminate or not, if I put x equal to 0 here, so what I will get? Minus 7 by 2, right? If I put x equal to 0, so this is not correct, right? So this is not a correct option. Let us check for this. You can simply put the values, that is 8 plus 4, 16 minus 12 minus 7. It will be 4, 20, 24, 27, say 4, 50. 12 minus 7, that is 5, that is correct. This one is correct, right? Now let us check for this option. Hello? Yeah. So what is the factor for this? X minus 3?
The whole square.
The whole square, right? It is x minus 3. So I can simply cut this out. So if I put x equals to 3, I will get 0, right? So this is not correct. So this is not correct option, right? So my A and C are the correct option. So we'll study in the derivative what is L-Hospital rule. So in that we can differentiate both numerator and denominator if we get the indeterminate form. Okay. So yeah. So any doubt in this part? Week 7.
No, sir.
So in the week 7 we have just studied the limit parts, like what is the limit of sequence, how to find out. Then in week 8 we have discussed the properties of limit and then what is continuity. Okay. So there are some useful rules regarding the continuity. I have copied this from the slides only. You can go to the slides. Okay, so now what is continuous function? Function is said to be continuous if it is continuous at all points in the domains for all the points for which f is defined. Okay, here you can see f of a is defined. If I consider previous example, that is x square minus 10 upon x minus 3, say limit x tends to 3. So here I will get the limit that is 6, right? But it is not equals to f of a. It's not equals to f of a. So for this particular function, limit exists, but it is not continuous function at x equals to 3. Okay. So what I mean a continuous function? There are two important things. That is, first one, limit should exist. Limit should exist means what? Left hand limit must be equals to right hand limit, right? Then there should be a limit must exist. It means left hand limit must be equals to right hand limit, and then we're going to use in order to solve the problems. Okay, so please remember this point. So that's all. So let us solve a few examples. Yeah. Okay, so tell me in this question at what point I have to check the, okay, so here I have to check whether f of x is continuous or not. I have to check this, whether this function is continuous or not. Yes, anyone, how to proceed further? Yes.
So there are 2 points in the whole range where there are 0 and 1. It's
Yeah.
the value is changing. So at those values, you need to test the limits from the left and right hand.
Yeah, correct. So let us check for 0. Okay. Let us check for 0. So what is left hand limit? That is limit x tends to 0. So basically my function will be 2 of x because we are going from the left hand side. It is less than 0, right? So 2 of x. So what will the answer? 0. What is will be the right hand limit for this limit x tends to 0?
It's
0
0.
already 0 only, right? So that is 0. So here my left hand limit is equal to right hand limit. So I can say that this function is continuous. So f of x is continuous at x equals to 0. Okay. If it is less than 0, it is continuous. If it is between 0 to 1, it is also continuous. It is 0. Now I have to check at this particular point. It is 1. So now let us check for 1. Now limit x tends to 1. So I'm going from the left hand side. Okay, so left hand limit, it will be 0 only, right? So it is 0. Now let us go from right hand side. Right hand limit x tends to 1, 4 of x. So answer will be 4, right? So here my left hand limit is not equals to right hand limit, right? So I can say my f of x is continuous at x equal to 0, but not continuous at x equals to 1. Okay. So this function is continuous at x equals to 0, but not continuous at x equals to 1. Okay. Anyone, any doubt? Okay. So here in this question, you have to find out the k. Find the value of k. So this function is continuous. It is given to us. This f of x is continuous, and then find the value of k. How to do that? Just
So we
apply those concepts. What you have just
the left and the right
limit
hand limit.
x tends to
Equate
a,
with.
f of a must be equals to, f of x must be equals to f of a, right? So here we have to check for x equals to pi by 2. If I say to calculate this for a particular function, it is a into cos of x pi minus 2x, right? So this function is not defined at x equals to pi by 2. So how to evaluate this? Just anyone? If I put x equals to pi by 2, what I will get? It is cos of pi by 2, and here pi minus 2 into pi by 2. So basically I will get 0 by 0 form, right? This indeterminate form, right? So here I can apply L'Hospital rule. So what will be the derivative of this function? Numerator and denominator, it is
Minus k sine x.
Yeah, so minus of sine x, right?
Yeah. Minus
here?
2 upon minus 2.
1 pi
Minus 2.
minus 2. Yeah. So limit x tends to pi by 2. Now this limit will be, if I put x equals to pi by 2, sine pi by 2 will be 1. So minus minus will get cancelled, that is k by 2. But this function is continuous, so this condition should satisfy, right? My f of a is given to me, that is 3, that is x equals to pi by 3. So this k by 2 is equals to f of a, that is 3. So it means k equals to
6.
6, right? So you can expect some type of example like this, like you have given the function f of x, it is continuous, and find the value of any unknown function, say a, b, c, d. Okay. So just remember one point. So this one important thing, like limit x tends to a, f of x equals to f of a, and before that we have checked the limit exists or not. So left hand right limit equals to right hand limit. Okay. So these two conditions are necessary for any continuous function. If you apply this, you can able to solve any problem. Okay. So now we'll move on to a differentiability. Okay, so let f be a function defined at open interval a, then f is differentiable at a if this particular limit exists. Okay, and this, if this limit exists, then that value will be equal to the derivative of this particular function, that is f dash of x, right? So now let us take one example. So suppose my f of x is x square. Say my f of x is x square. Okay, now I want to check whether this is differentiable or not here. And what is the value of this f dash of x? So just simply apply this thing concept. This limit h tends to 0, that is f of x plus h the whole square, that is x plus h whole square minus f of x, that is x square upon h, right? So what will the limit? Limit h tends to 0, x square plus 2h plus h square minus x square upon h, right? So x square will get cancelled. I can take h comma, right? If I take h comma and cancel it out, what I will get? Sorry, it will be 2x, right? 2x plus h. So simply put h equals to 0, so I will get 2x. Derivative of x square is 2x, right? So by this definition, you can find out the standard derivative also, right? So simply remember this thing. Now, one important part is that if the function is continuous, if f of x is continuous, can I say it is differentiable also?
Yes.
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 No,
If my
no,
function is continuous, can I say it is differentiable or not?
no, we cannot say it is differentiable.
No, we cannot say that, right? But reverse is true. If my f of x is differentiable, now can I say that my function is continuous?
Yes, sir.
Then f of x is continuous. Okay. So the best example for this is just take mod x. Okay. So whether mod x is continuous at x equal to 0 or not? Yes, anyone?
It's
continuous.
continuous, but not differentiable.
Yeah. Why it is not differentiable?
Because the left hand limit is -1 and the right hand limit is +1.
So if I say mod of x, right? So it means it will be equals to minus x if my x is less than 0. X if x is greater than or equal to 0, right? So now if I want to graph of this particular mod of x like this, right? This function is basically continuous at x equal to 0. So how to check? We have to check the left hand limit and right hand limit at x equals to 0. If I check left hand limit, basically limit x tends to 0, right? It is minus x this side. It will be 0 only. Now right hand limit will be 0 also, right? X tends to 0, x 0 only. So I can say this f of x equals to mod x is continuous. Because whether differentiable or not, how to check that? So I can apply the same definition here. Just see limit h tends to 0. So okay, so first we calculate left hand limit. Okay, what is the left hand limit here? Limit h tends to 0, f of x minus h minus f of x upon minus h, right? We are going from the left hand side. So if you put what you will get? Minus x.
Even -1.
Then h will get cancelled. So f of x minus h will be x minus h minus x, right? So it get cancelled out. I will get 1 here, right? Now right hand limit h tends to 0. Right. So I'm going from the left hand side. It will be x of h. Yeah, it is correct, right? Mod of x. Sorry, x plus h. So I will get here -1. Now here if I put x plus f of x plus h minus f of x, and we are going from right hand side, we have to consider this as h, positive h. So in that case, what I will get? H plus h minus of x upon h. So cancel, I will get 1. So this left hand limit is not equal to right hand limit. So this particular limit does not exist, right? So I can say this function f of x equals to mod of x is not differentiable at x equals to 0. Okay. So just remember this thing, like by applying this definition only, you can find out any standard derivative or you can solve any problem. Okay. So any doubt in this part? So if you understand what is continuous and differentiable function, then we should be able to solve this particular problem, right? So we have given this function f of x, okay, and if f is continuous and differentiable at x equals to 1, then what is the value of this, right? So I have given f is continuous. F is continuous, right? What is f is continuous means? Limit tends to a. So here a is 1, right? F of x must be equals to f of 1, right? Before that, one more condition is that my left hand, this limit should exist, right? So left hand limit must be equals to right hand limit. So if I consider left hand limit, so limit x tends to 1. So I'm going from the left hand side, okay, from this side. So it will be k square plus l. So what will the value? It is k plus l. Now what is my right hand limit? This limit x tends to 1. I have to consider this function because I'm going from right hand side, right? That is l x square plus kx plus m. What is the value? L plus k plus m. But as f is continuous, then this limit should exist. Means left hand limit must be equal to right hand limit, right? So x plus l equals to l plus k plus m. So this will get cancelled. I will get m equals to 0. Right? So I get m equals to 0 here. Okay. We have checked the first condition. Now second condition is it is differentiable at x equals to 1. So we have used this property of continuity to get this m equals to 0. Okay. So yes, anyone? How to check? Okay. So how to find out next thing? I have given it is differentiable at x equals to 1. So now this particular function is differentiable at x equals to 1. So my left hand differential limit will be like 2x. If I differentiate this f of x, it will be 2kx. L is constant here, right? That is 0. And if what if I differentiate this particular function, f dash of x, it will be 2lx plus k. But since it's differentiable at x equals to 1, I can equate these two things, right? So if I equate, what I will get 2lx plus k equals to 2kx, right? But at what point will you differentiate at x equals to 1? So I can simply put x equals to 1 here, but I will get 2k, and here I will get 2l plus k. So here I can say it is 2l plus k equals to 2k. So 2l equals to k, right? So this is one more condition I got. So what I have to find out? K minus 2l. So k minus 2l. So I can put 2l equals to k, right? And plus m equals to 0. So what I will get? 0 only. So answer of this particular function f of x, that is 0. Any doubt in this problem? Yes, anyone?
Piyush, I have a question. See, once you differentiate, you have to substitute the value of x to get
X
the
equals to
actual
1.
value.
Yeah.
Okay, okay.
I should directly wrote it here, but so I should mention like this. So this f dash of 1 is differentiable at x equals to 1. So I will get 2k. Similarly for this function also. Okay. So now there are some useful rules about the derivative. So there's linearity function. I can transfer the derivative like I will do derivative. If f of x is differentiable at point A and C belong to R, then this constant, if we multiply by constant function, is also differentiable at point A. Okay. So you can remember this point, and same for the minus also. Okay. So what, like if you see what is this property means, if I given this function f of x, so x cube plus 7x square, say 2. So if I want to differentiate this t of f of x, I can transfer this derivative to each individual term, that is x cube plus ddx of 7x square plus ddx of 2, right? It can be minus also, no issue. Same thing. I can take constant outside, so it will be 3x square plus 7 into 2x plus the derivative of constant function is 0, right? So it will be 3x square plus 14x. So please remember some standard derivative like derivative of constant function, derivative of x to the power n, and what is the derivative of log x. So all those things you have to remember. So now let's check for the product rule. So we have two functions f of x and g of x which are differentiable at a. Then so this f of g, sorry, fg of x. If I want to differentiate two functions like this is f and this is f of g, what I will do, it is how to differentiate this particular function dd of x. So just take the first term, differentiate the second term. So I will keep the first term as it is, that is x minus 3. I will differentiate the second term, that will be second term like 3 only, right? And plus, take the second term as it is, that is 5 plus 3x, and differentiate the first term, that is x minus, or x to the power minus 3. So it will be minus 3 x to the power minus 4, right? So my answer will be x 3 into x to the power minus 3 plus 5 plus 3x minus of 3 x to the power minus 4, right? The simple product rule. I can take one more example like x sin x. How to differentiate this particular function x into sin x. Just take one function as it is, differentiate the second function, that is sin x, that is cos x, plus keep the second function as it is, that is sin x, and differentiate the first function, that is 1. So x cos x plus sin x. Any doubt in this product rule? Hello?
No doubt.
Okay, so now about the quotient rule here. So f of x and g of x differentiable at the point A, and g of a should not be equals to 0, right? So g of a should not be equals to 0. So how to evaluate this particular quotient rule? Okay, so how to apply this quotient rule here? So if I want to differentiate this particular function, what I have to do? Yes, anyone can tell me what is f dash of x here? Do I have to apply the quotient rule here? This term? What will be the differentiation of this particular term? Yes, anyone?
X plus
You
1 का whole square divided by x plus 1 का whole square, x plus 1 into में and differential of 2, that will be 0, minus differential of x plus 1 into 2.
I can do that also. If you consider this as a f of a. But if you consider this is basically my 2 of x, right? So x plus 1. So I don't need to consider this constant function. This is constant, right? So I can take it outside also. I can directly apply the derivative of 1 by x here. This what is 1 by x derivative? Composite of this function plus 1. What is the derivative of this particular thing?
minus 1 by x plus 1 का whole square.
Minus x 1 by 1 x plus 1 का whole square. Okay. So if I have like this function, say ax plus b, if I want to take the derivative of this, so what will be derivative? Minus 1 ax plus b ka whole square plus derivative of this particular function, right? So in this case, our a is 1 only, right? So I can directly write down as minus 1 of x plus 1 ka whole square. You can also consider this as 2 as f of a and apply this, you will get the same expression. Okay. Now what about this particular term? Square upon 3x minus 1. So just take the denominator, that is 3x minus 1, differentiate the numerator, that is twice x, minus keep the numerator as it is, that is x square, and differentiate the denominator, it will be 3 only, right? 3x minus 1 ka square. So what I will get at the end? Minus 2 x plus 1 ka square minus 2x 3x minus 1 minus 3x square upon 3x minus 1 ka square. Right? This is how we apply the quotient rule. Okay. Any doubt in this part?
No.
Okay.
No, sir.
Okay, so now let us solve this particular problem. F of x is given to us, that is f of x equals to log of 5 of x, and we have to differentiate this function. Okay, we are given the hint also. Yeah. Yes, anyone? So we have the differentiation of log x, right? Log x to the base a. What is differentiation of log x to the base a? Anyone? What is the derivative of log of x to the base a?
1 by x.
By x. What about the base?
A log ax.
Yeah. So we have standard derivative, that is log to the base e. Okay. So log to the base e of x, that is 1 by x.
1 by
Okay.
x.
Yeah. So here, if you want to apply that particular this thing, you can simply apply the base change formula, log e to the x upon log e a, right? Now this term is constant now, right? And directly I can take this derivative of this particular function. So what I want to say is, this is my constant, right? So 1 upon log e a is constant. I am to take the derivative of this particular function, log of it to the base x. So now I can say that this derivative will be 1 by log of e to the base e into 1 upon x, right? So that will be 1 upon x log to the base e. Okay. So in general, can I say that derivative of this particular function will be 1 upon x log of a, right? Directly I can say, without applying base change formula also, you can remember like this. It is 1 upon x log of a. So we cannot apply this differentiation directly here, because we don't have the differentiation for log of a to the base x, right? So that's why we're applying this rule. That is, the hint is given to us, this log based property, right? So my f of x will be 1 upon log of x 5. Now I want to differentiate this particular dt of x. Just anyone can tell me what should be the differentiation of this? This is basically a composite function of 1 upon x, and then g of x will be log of 5 to the x, and this is my f of x, right? So what I have to do? Tell me, is anyone? How to take the derivative of this?
You can write it as log of x to base 5 raised to minus 1.
Sorry, log of
X to base 5 raised to minus 1
5
raised to minus 1.
raised to minus 1, okay.
Yeah. So that makes it minus 1
Minus 1 upon
log of x. Okay.
Yeah.
Multiplied by.
log of 5x to the power minus 2, right?
Yeah.
So I
And
can
then-
write,
And then you differentiate log of x to base 5.
yeah. So then it's a differentiation of this composite rule, right? So differentiation of this particular function will be minus 1 of log of 5x whole square into derivative of this particular function.
1 by x
1
ln
by x into log of
natural log.
this natural log, the base.
5.
So the correct option will be this one, right? Yes. Yeah. So anyone, any doubt in this problem? We should know the standard.
Sir, may I say something?
Yes, yes.
Sir, we have created a WhatsApp group to discuss study materials among ourselves. If you have no problem, then you can join this group. If there is any problem, student can inform you. Their group links are in the chat section. If there is no problem, you can join, sir. Thank you, sir.
Sorry, I didn't get that right.
Actually, Shavik, I'm not able to, the link is not working. I'm not able to join.
Oh, I see.
Yeah. Bye.
Yeah. Okay, I
You
create a
can
new
discuss
link
that part.
for you.
So I'll not be here for the first
Okay.
week next week, but you complete the workshop.
Hello?
Yeah.
Yeah,
Yeah.
please mute yourself. Yeah. You can discuss in the chat.
Okay, sure. Thank you, sir.
So now what about the chain rule? The proper composition of a chain rule that we have applied earlier. So it's how to solve, how to apply this particular chain rule. So suppose I have given a function f of x is like this. Say sine of please mute yourself. Yeah. Sine of cos of, say, e to the power x का cube. So this is my f of x, okay, and I want to differentiate this particular function. So what, according to composition of chain rule, is I have to differentiate this first function, that is cos of f dash of x, is cos of this particular whole thing, right? The differentiation of cos sin x is cos x, right? Cos of x cube, right? Into differentiation of this function, that is cos x, that is minus sine of x cube, right? Into differentiation of this particular function, that is e to the power x cube. That is e to the power x cube is e to the power x cube only, and then differentiation of x cube, that is 3x square. So this is how a differentiation will be there. This is a composite function, having the three composite function here. So I'm just taking the derivative of outer function, that is sine of x, that is cos of x. Then the derivative of inner function, that is cos of x, that is basically minus sine of x. Then derivative of this particular function, e to the power x, that is e to the power x only. And then x cube ka derivative, that is p into x square. Right? So any doubt in this thing, chain rule, how to apply? Hello?
So we go from outward to inward, right? From outside, we go inside.
Yeah.
Okay.
Same thing is applicable here. You can see f dash of x, f g of x, then into differentiation of this inner function. Similarly, you can take simple example, say sine of x to the power 5. Okay. So what is the differentiation of this sine of x to the power 5? That is basically a cos of x to the power 5 into differentiation of this x to the power 5. That is 5 x to the power 4. So just remember this chain rule. You can get simple question based on this rule also. Okay. Okay, so now about the L'Hospital rule. Okay, so suppose if you are finding out the limit of these two functions, say like this, f of x upon g of x, and if you are getting 0 by 0 form or infinity by infinity form, okay, so this basically it is called as indeterminate form. Okay, determinant. There are also other indeterminate form like infinity raised to power 0, infinity minus infinity. Okay? So if you are getting such form, then you have to convert this particular form into 0 by 0 and infinity by infinity. Then you can apply this L'Hospital rule. Okay. So if you are getting this form, if after putting the limit, what you have to do, you have to differentiate the numerator and denominator differentially. That is CDF of ddx of f of x upon ddx of g of x. Okay. Please remember here we don't have to apply the quotient rule. It is not equals to ddx of this thing. Right? This is not equal. These two are different things. Okay. We have to differentiate the numerator separately and denominator separately in order to apply L'Hospital rule. So let us discuss one simple problem. Yeah, here. So in the following option, one can apply L'Hospital rule to evaluate the limits. Okay. Just try to put x equal to 0 first. What I am getting? 0. That's 0 plus sine of 0, that is 0. Here I am getting 0 by 0 form, that is indeterminate form, right? Determinate form. So I can apply the L'Hospital rule here. So what I have to do, I have to simply take the differentiation of numerator and denominator, right? So if I apply the differentiation, what I will get? 1, if the derivative of x is 1 here, the numerator, and the denominator, what I will get? 1 plus cos of x, right? Then you apply the limit x tends to 0. So here, now what I will get? That is 1 plus 1 by 2. That is 1 plus cos of 0 is 1. This 1 by 2. Okay, anyone try this problem? Yes.
And the answer comes out to be 0.
0 by 0.
Numerator, you get it as 0.
So we need to differentiate this function, right?
Yeah, so it becomes 2 sin x cos x.
2 sin x cos x.
Yeah, and the denominator becomes
0.
0 minus
Differentiation of cos x. Yeah.
plus sine 2x minus
sin
sine
2x
multiplied by 2.
Yeah. So what I will get, limit x tends to 0, 2 sin x into cos x upon 2 sine 2x. Now what I have to do?
You
Hello. Yeah, you are not audible.
you can cancel out the 2
Mhm.
and expand sine 2x as 2 sin x cos x.
That we can also do. Here also I can do like 2 sin x into cos, basically sin 2x only.
Okay.
Sin 2x upon 2 sin 2x, right?
Yeah, that gives you
This will
half.
get cancelled. It will be 1 by 2 only. Answer will be 1 by 2. So anyone, any doubt in this problem? You can try out this thing. Like if I put x equals to 0, it is not defined, right? Here also 0, it will get 6. So here I cannot apply the L'Hospital rule. Here it's giving me infinity only, right? It is not an indeterminate form. Okay, any doubt in this L'Hospital rule?
Piyush, I have a question. See, in the numerator, you get 7, for the third question, you get 7 plus 1 by x. And the bottom, you get 3x square. Okay, 7 plus 1, okay.
Okay, 7 plus 1 by x.
1 by x, and then at the bottom, you get 2x square, right?
2x.
Square, right? So the thing is, can you differentiate it further? Or you are only allowed one differentiation for L'Hopital's rule?
Sorry, I am not getting 2x plus 2x only.
No, it's like 2x square, 3x square, 3x square.
Okay, differentiation. Okay, you want to
Yeah.
differentiate this function.
Yeah,
But it is not an indeterminate form. If you put x equals to 0 here,
yeah.
it does not exist, right?
Yeah, but what I'm asking is, suppose you put the differentiation again, it's coming to a 0 by, it's coming infinity by 0 form. So you can't differentiate it further, right?
Yeah, so if you consider this,
Yeah,
it will be 7 because it will be infinity, right? So infinity by 0 form.
yeah. So L'Hopital's rule is only applicable for 0 by 0, not for infinity by 0.
Infinity by infinity, yeah.
Okay, great.
Instead of 0, if it is infinity, then we can apply a hospital rule. Instead of 0, if it's infinity, then you can apply a hospital rule.
Got it.
Yes, I will
Yeah.
get infinity by infinity. If I get infinity by infinity, then what will the answer? 7 will not be there now because differentiation of 7 will be 0 only. So 1 by x, 3x plus square. Right? So here I will get 3x to the power, that will be 0 only. If I take x equals x tends to infinity, right? Limit x tends to infinity. Okay. Now in the last part of this week 8, we have learned about tangents and derivative. Okay. So let's f be a function differentiable at point A, and the tangent of to f at A exists and is given by this, like y equals to f dash of a x minus a plus f of a. If you have any function f of x, you have to find out the equation of tangent at a particular point A. You need to simply differentiate this function, put the value a, then x minus a plus f of a. So this will give you the tangent, equation of a tangent, this particular curve at point A. Okay, it's a simple thing. You just note it down. Remember this thing. And in case of linear approximation, say suppose if you are given a complex function f of x and you have to find out a value of this function at say some certain point. Okay, so you can do by linear approximation method. Say for that, what we have to do, if f of x is differentiable at a, then best linear approximation is given by L of x equals to f of a plus f dash of a x minus a. So same thing is applicable here also. Yeah. So now, okay, just remember this. For a value x, sorry, 1.01. Okay, so what is the expression here? That is y equals to f dash of a x minus a minus f of a, right? Plus f of a, right? So I have to take the differentiation first. What is the differentiation of f dash of x or f of x? 4 into 1 plus x cube, right? So at point x equals to 0, I have to find out. So at x equals to 0, what I will get? 4 only, right? If I put here, that is 4, x minus 0, I will get 1 only, right? So f of 0 is 1 here. So what I will get? 4x plus 1, right? This is my linear approximation, linear approximation L of x. But now what I have to find out? I have to find out the value of 1.01 to the power 4. So if you compare this with f of x, that is 1 plus x to the power 4. So what should the value of x in order to get 1.01? If I put x equals to 0.01 here, so I will get 1.01, right, to the power 4. So if I put x equals to 0.01 plus 1, so I will get 1.04 as the approximate answer, right? Any doubt in this problem? Anyone? It's, I think, activity question only. No.
Can you explain what is the purpose of linear approximation? Like, what are we doing generally?
In general, so suppose you have f of x, any complex function is given, and you have to find out the value of f of x at any particular point, say a. So in that case, if you say there is a complex example, it will be difficult to find out, right? So you just go through the linear approximation method. You simply divide, differentiate this function f of x, put the value at a particular point a, then x minus a plus f of a. If you follow this particular linear approximation, you will get the approximate value of the particular function at point a. So this complete the week 8. The main important part in the week 8 is continuous function, continuity. So whether the function is continuous or not, or some you can expect an question from this limit or like hospital rule. Okay. Yeah. So you can go to the slides also. So now let's discuss about week 9. Okay. So here at first we'll start with the maxima and minima. So hello. Yeah. So what is the concept of maxima and minima? Yes, anyone?
Is that value of the graph where the derivative becomes 0?
Yeah.
The point x where the fx will gain its maximum or minimum value.
So suppose if I have function f of x, right, and I have say domain say from a to b. So in that particular domain a to b, then this my function will attain the maximum and minimum value. So that we have to find out by using maxima and minima. So there are two different steps. So at first we have to find out the critical point. That is find all critical points. Okay? Critical points of f of x. So what is critical point? Anyone?
The point where the function attains a maximum or a minimum.
Yeah, so I can say that point where the so suppose this I have right? So this, I can say this is a critical point. It will attain the point at which the particular function will increase, and particular after that particular point it will decrease, right? F of x, I can say that it is critical point here. Right? And how to find out this critical point? If I given the function f of x and I want to find out the critical points, how to do that? So in second step, you have to find out f dash of x, right? You have to equate that f dash of x equals to 0. Say if you are getting the value x1 and x2 are the root of this f dash of x equals to 0, then what you have to do in the next step, just find out f double dash of x. It is the second derivative test. And if this second derivative test at x equals to 1, so that is f double dash of x equals to 1, if I are getting the value greater than 0, this positive value, then I can say at x equals to 1, f of x will get minimum value. Minimum. Okay. Minimum will occur. If I am getting f double dash of x1 less than equals to 0, that is negative answer, so I will get at x equals to 1, f of x will get maximum. So there are 4 important steps. You have to find out the critical point first, and for that you have to differentiate this function f dash of x. Okay, and then you have to equate it to 0 and find out the roots of this particular equation, and just then take the second derivative of this particular function and try to put the values. If you are getting the value of this second derivative as positive, then we can say at this particular point my f of x will attain the minimum value. And if you are getting the negative value, then we can say that at f of this particular point, my function f of x will get the maximum value. And if it is equals to 0, then there is no maxima, there is no minimum. We call this as saddle point. So let us take one example. Say I have f of x as, say, 2x cubed minus 15x squared plus 36x plus 1. Now how to find out the maximum minimum of this particular function? Okay, so there is one more concept about global maxima and minima. Second one is local maxima and minima. Yes, anyone tell me what is the difference between local and global maxima minima?
There can be multiple local maxima, but there can only be one global maxima.
So can I say my global maxima is my local maxima also?
What is the local maxima?
Say my global maxima is also local maxima.
Yeah.
Okay, so say interval is 1 to 5. Interval is 1 to 5. Now what is the first step? We have to find out the critical points. So for that we need to differentiate it, right? So f dash of x will be 6x squared minus 30x plus 36, right? We have to equate this equals to 0. So I can take 6 constant y and equate to 0. So I will get x squared minus 5x plus 6 equals to 0. I have just taken the 6 common. Okay. Now, what is the factor of this particular expression? X minus 3, x minus 2 equals to 0. Right? That is x equals to 3 and 2. So my critical points are x equals to 3 and x equals to 2. Okay. So now in order to check whether this function f of x at particular point 3 return the maximum minimum value, what I have to do, I have to take the second derivative of this particular function. So what will be f double dash of x? So it will be 12x minus 30. Right? Now just put f double dash of 3 at x equals to 3. What I will get? 12 into 3 minus 30 equals to 6. And here what I will get? F double dash of 2 equals to 12 into 2 minus t equals to minus 6. So here I am getting the positive value, right? So I can say at x equals to 3, I will get minima value. Okay, that will be my local minima. X equals to 2, I can say I will get the maximum value. That is my local maxima. Okay.
Piyush,
Yeah.
so when you draw the graph of this function, it's actually a parabola that cuts at 2 and 3. So
Which one?
neither 2
This
or
one.
3 can be the maximum minima. The minima lies at x equal to 2 minus 2.5.
No, we are talking about this function. You have plotted the graph for this function, right?
Yeah,
You will get 3 comma 2. It is basically it will cut the x-axis at 3 and 2, right?
correct.
This 3 and 2. Yeah. So we have to find out the maximum minimum value of this particular function f of x, not f dash of x.
Okay, got it.
So now this is local maxima and minima. In order to find out the global maxima and minima, what I have to do, I have to take the boundary intervals, that is 1 and 5. So f double dash of, this is suppose I have not given this any interval, I have to find out the local maxima and minima. So in that case, my answer will be at x equals to 2, I will get the minimum value, and x equals to 2, I will get the maximum value. So what would be my value? At f of 3, 2 into 7 minus 15, 9, 36 into 3 plus 1. Okay. So here you will get 54. Here. I have double dash of 2, 8, 16 minus 15, 460 plus 36 into 2, 72 plus 1. 12, 16. Correct, no? 16, 72, 12, 12 and 16, 20, 29, right? So I am getting my maximum value at x equals to, that is 29, and at x equal to 3, I am getting 20. This is my local minima. Now, in order to find out global maxima and minima, I have to compare this value with f of 1 and f of 5 also. Right? So what is my f of 1 here? Let's put 2 minus 15 plus 36 plus 1. Right? So I will get 24. And here I will get 2 5 ka cube minus 15 into 25 plus 36 into 5 plus 1. So here I will get something value, right? So if you see now at f of 1, I am getting 24, right? So my local minimum will be f of 1 here. Sorry, not local. My global minimum will be 1 here because I'm getting the value 24. It is less than my local maximum, local minimum. It is 28, right? So in this case, my global minima, or I can say absolute minimum, will be at f equals to 1, at x equals to 1, that is 24. If I calculate this, I will get 56. If you see at x equals to 5, I am getting f of 5 as 56, right? So if you compare this f of 3 and f of 2, I will get a global maxima at 5 and global minima at x equals to 1. Okay. So if you are asked for only for local maxima and minima and you are not given any interval, you can simply find out a critical point and find out the value of this f of this particular points. Okay. Any doubt in this problem? Just remember this 4 steps. Differentiate the function, equate it to 0, find out the roots, then take the second differentiation, put the value of the roots. If you are getting positive value, then at that point I will get the minimum value. If I'm getting a negative value, then at that point I will get the maximum value. Okay, and if you are asked for the global maximum minima, then you have to simply put the boundary intervals f equals to 1 or 2, like a or b, anything. You have to compare with the local maximum and minimum. Okay. So suppose if I put x equals to, say in case of here 1, if I put x equals to 1 here, and I'm getting say some less value, say 20, 30 value. So in this case also, my f of 3, that is x equals to 3, will be my local maximum, sorry, local minimum. Because as f equals to, I am getting 24, right? This is my local maximum. So just remember this 4 simple steps, nothing in that. You can simply do that. Any doubt in this? Any maximum, minimum, anyone? So computing area is basically a simple topic. If you know the standard areas of say square, and second is rectangle, third one is circle, fourth one is trapezium. Okay. So if you know the area and perimeter of all the 4 standard shapes, then you can easily solve any problem. Okay. So now let us take one problem here. So okay. So a circle C is inscribed in a square S1. There is one square, that is S1. Right? It's S1. And circle C is inscribed in a square. So I can say this circle C. This circle C is inscribed in a square S1. And then a smaller square S2 is inscribed in a circle C. This is my C, right? So now the square will be like this. Okay. Consider it as a square. This is a S2. And suppose the ratio of area of S1 and S2, S1 and S2 is m by n, and find out the value of m plus n. So what is the area of square here? So suppose it is A. So yeah, so can I say this length A is equal to the diameter of this particular circle T? Can I say this?
Yes.
Yeah, this is also my diameter. If I join this to endpoint, this is also my diameter, right? So if I take the inner square, it will be like this, right? Square, and it will be a diagonal, and that is diameter of this particular circle, right? Now if this is the diameter of this particular circle AD, then what should be the length of the side? With this square, right? Angle is 90 degree. So let's say it is x. I can apply Pythagoras theorem, that is x square plus x square equals to d square. So it will be 2x square equals to d square. So x equals to d by root 2, right? So x is d by root 2. And here a is equals to d. So simply put, what is the area of square? S1. And S2 will be x square, that is d by root 2 ka square, right? Will be d square by 2. If I take the ratio S1 and S2, what I will get? D square upon d square by 2. It will be 2 by 1. Okay. I can equate this with this ratio, that is m is 1. Okay. And you can say this GCD m minus equals to 1. This condition is satisfied. So I can say m plus n equals to 2 plus 1, that is 3. Right? So you just know to remember the standard area and perimeter of the shapes, like square, rectangle, circle, and trapezium. Okay. Any doubt in this problem? Okay, so next topic is Riemann sum integral. Okay, so here what you are doing, so suppose I have function f of x. This is my function f of x, and I have the interval a to b. It can be any interval a to b. Now I want to find out the area of this curve from a to b. So what I can do, I can simply divide this curve into number of rectangles like this, and then I can find out the area of each rectangle, right? And then I can sum it. So in that way, I will get the area of this curve from A to B under this A to B, right? So what we are doing in Riemann sum integral is same thing, right? So we are just dividing this part in the number of intervals. So what is that? This del of xi. This xi xi minus 1. So what is it? Let me draw bigger picture. So I will take one graph. This one. Okay. So this is B. This is A. 1, 2, 3. I can see this is x1, x2, x3, x4, and x5. Okay. Now, if I want to find out the area of this particular rectangle, what I can do? I have to find out the width plus into length, right? So width will be x2 minus x1 here. Right? So that is our LXI. LX also same thing, right? Xi minus x of I minus 1, right? X2 minus x1. Right. So I will get del xi. Now, if I get the width here, I want the length also in order to find out the area of rectangle, right? So what I will get length by putting the value of x1 x2 in particular function, that is f of x. I will get this value. If I put f of x1, I will get this one. If I put f of x2, I will get this one, right? This one. So I can simply multiply by f of x1 into this particular length, that is del of xi. I can do this for all the rectangles and then sum it. So in this way, I will get the area of the curve from A to B. Right. So same thing we are doing here is a Riemann sum f with respect to above data is defined as this Riemann sum combination of I n values from I to n f of xi star and del of xi. So this is basically my width of the rectangles and these are my length of the rectangles. I'm just summing it out the area of all the rectangles. Okay. So just remember this thing, and you will be given in the question that what should be the xi star and what should be the xi. Okay. So interval will be given to you. So del of xi will be xi minus 1. And x star will be belong to xi minus 1 to xi. So I can take any length, right? I can take this also. I can take this one also. Okay. So it will be from x1 to x2, or x2 to x1, anything, right? So this is the expression for Riemann sum integral. Okay. So another way is to find out the area under this curve. It's just simple integrate it from A to B, take f of x. Okay. So which is my equals to this particular thing here you can see. Right. So in this Riemann sum integrals, remember two important things. The first one is this is the expression for that, and del xi is xi minus 1. And for xi star belongs to this particular interval. Now, what is the norm of P? It is a norm of P. It is a maximum of del of xi. In some of the question, you can see that del of xi is constant for every, but in some cases it will be varying also, right? So maximum of del of xi will be called as the norm of P. So let's see. Any doubt in this part, conceptual part, Riemann sum integral? Okay. So we can go on to a question. Like here we have given xi star is equals to xi, and we have to find out the value of this particular function. For f of x is x from 0 to 5. So if I calculate 0 to 5 f of x, that is x dx, what will the value? X square by 2, right? That is 0 to 5. That is 25 by 2. Now I have to prove this whether this integration is correct or not by using this Riemann sum, right? So how to evaluate? Yes, anyone? We have given s of p, that is Riemann sum is limit tends to infinity, summation of I equals to n f of xi star to del of xi. Now what is del of xi here? Del of xi is xi minus xi minus 1. So if you put xi and xi minus 1, what you will get here? You can take simple these two also, like 2 to 5 by n minus 5 by n. So you will get 5 by n, right? So here del of xi is 5 by n. Okay. Right. So what is xi star is given to x of I, right? Yeah. So that will be. Yes. Now how to evaluate this? Anyone? X of I is given this I into 5 into n. So if I put this value, I will get limit n tends to infinity, summation of I equals to I values from 1 to n. F of xi means xi is given to me, that is I into 5 by n into del of xi, that is 5 by n, right? So it will be limit n tends to infinity, summation of I is from 1 to n, I into 25 by n ka square, right? Yeah. So now tell me what I have to do, how to solve this particular limit. Yes, anyone? A hint is given to you, right? So I can take this as constant outside. It is 25 n square, that is limit n tends to infinity, summation of I equals to n I, right? So summation of I is from 1 to n is basically like this, like 1 plus 2 plus 3 plus s. So it will be equals to, I can write limit n tends to infinity 25 upon n square into this, right? That is n into n plus 1 by 2. I can cancel it out n, so what I will get 25 n plus 1 upon twice n, right? So how to evaluate this limit? Limit n tends to infinity. I can take 25 by 2 common, and n plus 1 by n. Okay, so 25 by 2 limit n tends to infinity. So 1 plus 1 by n. I'm just differentiating, right? So here, if I put n equals to infinity, I will get 0. Output will be 25 by 2. Answer will be 25 by 2. Here you can see we got 25 by 2, right? Hello? Anyone, any doubt in this problem? Hello? I'm audible, right?
Yes.
Yes.
Okay, so this is, in this way you can solve any problems. Now just this table of standard derivatives integral. Please refer to this. It is taken from slides only. You can go through it. There are some basic properties of definite integral also. You can go through it. Okay. While solving the question, you can apply those properties. Okay. So now one important thing here. Like suppose you have to find out the value of the definite integral. Okay. So say suppose I have function which varies from minus a to a and f of x dx. Okay. So here just remember one thing, like if f of x is a even function, if f of x is an even function, then it will be equals to that this integral will be equals to twice of 0 to a f of x dx. And if f of x is an odd function, then simply this integral will be equals to 0. Okay. Now here you can observe like minus 2021 to 2021, right? So just check whether this particular function is even function or odd function. If I replace x by minus x here, if I replace x by minus x, what I will get? This odd power of x, right? It will be negative only. Cos of minus x will be cos x only, right? So cos of 2021 x only plus, hello, yes, anyone? Okay, so if I replace x by minus x, so it will be minus of sin x. So it will be minus of sin of 2021 of x. So I can take minus common. I can write x to the power 2021 into cos of 2 into x plus sin of 2021 x. So basically it is minus f of x. So this f of x is an odd function. So I can simply write this integral will be equal to 0. Value of this integral will be equal to 0. If it is even function, then you have to evaluate it twice of 0 to a f of x dx. Okay. Okay, any doubt in this part? The special type of integral you can remember or note down. Okay. Yeah, so there are a few examples. Just tell me the approach that how will you approach this particular question. Yes, anyone? We have to find out the area enclosed by f of x1 and x2, right?
So we can find the area under both the curve, and we can subtract the area under the above curve from the curve which is like going through 0.
Yeah. So, but at first we have to find out the intersection point, right?
Yes, right.
Yeah, because we can take the integral from this to this.
Right. Integrate from this point to this.
I can find out the area of this parabola minus this parabola, so I will get the area of this. Just multiply it by 3, you will get the answer. Okay. Yeah.
Excuse me, sir.
Huh? Yes.
Can I ask a little loud?
Yes.
I wish to know, like, the real qualifier exam, the problems will be regarding the concept, testing the concepts, our concepts, or it will be more tricky from the things we are doing right now?
No, it will be similar to this one. So you have gone through practice and graded question, right? On portal.
Okay. So the main thing is just to like go through the concepts, right?
Yeah. Let's go to the concept.
Piyush, I have a question. See the videos which are posted for DS for Maths1, right? Those are videos we need to go through, right? Nothing extra.
You have given the portal access, right? Whole portal access.
Yeah.
Yeah. So that 12-week content is given to you, right?
It contains what?
12-week content. What 12-week content is there? Week 11 content. From week 1 to 11.
This is for Maths1, right? Not for Maths2.
No, Maths1 consists of week 1 to 11.
So I'm referring to the YouTube channel which they had given for the qualifier exam.
So Piyush, basically
we don't
for the
have
diploma,
portal access.
Okay.
so Piyush, for the diploma exams, we are not given week-wise contents. It's just a matter of maybe some selected, we don't know, but the contents of the various weeks one has been put up into a YouTube channel, and we are basically referring that one.
Okay. Just 1 minute. Let me confirm. Okay, just 1 minute. Yeah, so this content is part of those YouTube playlist, right? Hello, am I audible?
Yes.
Yeah.
No, actually the calculus part is not there on the YouTube channel.
How is it?
So the thing is, it's there.
Is there, no?
It's there in Maths1. It's not there in Maths1. It's probably there in Maths2.
No. Whole Maths1 content is there, right? So it is from week 1 to 11. Complete Maths1 content is there. Yeah, I confirm. Complete Maths1 content is there. Okay. We can go to the next question. Let's see. It's simple. The concept will be simple. Just what you are discussing right now. Simple. Just evaluate it. Okay. So yeah. Okay, you know the approach how to solve this particular question. How to solve this But we have to find out the value of f of x on a here. So at first we have to find out the integral here. It is integral of x log of 1 plus x dx. So how to evaluate this one? Does anyone? Okay, so at first we should will discuss. But here we have to apply integration by parts. Okay. So let's discuss one example before that. Okay, so before that, let's take one substitution example. So here, integration by substitution. Okay, so if you are given the integration, say f of g of x, and its derivative is given to you, g of x or g dash of x, you can simply substitute g of x equals to u, and then g dash of x dx equals to u. Okay, so I will take one example. Here is one example. Okay, so can you tell me what substitution I have to put here? I have to solve this integral by substitution method. What substitution I should put here? Yes, anyone?
Ten under root x is equal to u.
Yeah, we can put under root of x equals to u. And 1 upon, I have differentiate it, right? 1 upon twice root x dx equals to du. So
No,
do we have twice
no,
root
no,
x
no,
here?
no. Even 10 under root full 10 under root u can put u.
Yeah, we can directly put 10 under root x also, because already x square under root of x is given to us, right? If I put tan of root x equals to u, so the derivative of this tan of root x will be x square root x dx equals to du. Right?
Piyush, I need to hop to another call. We have a Python session from 6 o'clock. So, yeah.
Just two concepts are remaining. So
Okay, sure, sure.
substitution, and then last one is by parts. I'll take just one example. That's it. Okay, so if I put here du, right? So what is the derivative of differentiation of this tan of root x? X square root x into root x ka derivative, right? Derivative of root x also, that is 1 by 2 root x equals to dx equals to du. But here 2 is not there. So what I can do, I can multiply and divide it by 2, right? So my whole, hello, yeah, please mute yourself now. I just coming. So I can put this as du only, right? Twice of to the power 4 du, right? Now you can simply evaluate this integral. So 2 constant outside, integral of e to the power 4 is 5 upon 5, right? That is plus c, constant of integration, right? You can simply resubstitute that part, right? So okay. Can you please mute yourself? Noise is coming. Yeah. Now just resubstitute that part. Okay. So tan of root x to the power 5 upon 5 plus c. It is constant of integration. Okay. So if you can also put root x equals to u, then you have to resubstitute 2 times here, right? You can try out this example. Okay, so let's move on to the last part only. We have class. So it's integration by parts. Okay, so suppose I have x into sine x, right? I want to integrate this one particular function. So how to go about it? So you have to consider the first function and second function. You have to just take the first function as it is, integrate the second function minus integral of derivative of the first function into integral of second function, right? So what is first function, second function, how to decide? For that we follow one method, that is isolate. Okay. Yeah. So here I stand for inverse trigonometric, L stand for logarithmic, A stand for algebraic, T stand for trigonometric, A stand for exponential, right? So if I want to evaluate this particular integral, what should I consider first function here? Is anyone? If I want to evaluate integral of sin x, I can take this x as a first function, means I can keep x as it is, right? Or should I keep the sin x here? Yes, anyone? How to evaluate this particular function? Okay, so here you can see algebraic expression, right? I can consider x as a first term. So keep the x as it is, integrate the second term, that is sin x. So sin x integral, that is basically minus of cos x, right? Minus integral of derivative of this particular function x, that is 1, into integral of this function, that is sin x, that is minus of cos x, right? To simplify it, minus x into cos x minus of, so minus minus will get plus integral of cos x dx. So that is minus x cos x plus integral of cos x is sin x. Right? So plus c, constant of integration. So that's how we evaluate the integration by parts. Any doubt in this problem? Simple thing. Hello. Okay, I think this is the last part. There are a few examples. You can go through it. Right? Okay. It's taken from activity only. You can try out this example. Okay. So here you can consider, because if you consider any of the function here, you have to consider this as a I equals to this particular integral, and then just substitute I equals to this. Okay, and then solve it. Okay. So any doubt in any of this part? Anyone? Hello.
Hello, sir.
Yes.
Can you please share this PDF?
Okay.
Thank you.
And is it possible to get the recorded session of the prior sessions as well? Because I could not get to attend the earlier sessions.
I need to ask for that.
Okay, possibly all 3 sessions. I'm hoping we would have had 3 sessions.
Okay. So Subhashis
covering
is
all
there.
chapters.
Subhashis.
Yes, I'm here. So the thing is, I don't know, like I have informed them to upload, like to send you the link of that session. So I'll ask them again, and
Mhm.
I'll try to send you the recordings of both the sessions. Okay.
Okay, was there only 2 sessions conducted? I mean, including
No,
this?
the last so till now we have conducted 2 sessions. So one more session is there.
3. Okay.
Yeah. So still
Okay.
now we have
Okay.
conducted
Okay.
only 2
Yeah.
sessions. So there is one more session.
Mhm. Okay. Thanks.
Yes.
Yeah. So whatever we have discussed today, that is calculus part. So it is there in the qualifier exam. Okay.
Okay.
Yes.
Thank
Yes,
you.
Subhashis. You can repeat like what is the
Yeah,
syllabus?
so the syllabus is whole Maths 1. It's basically from week 1 to week 11, like including your graph theory part, calculus part, and your like this logarithm set theory. All these things are there in your syllabus. So the syllabus is complete Math 1. Okay. Anything
Okay.
else?
Where can we access all the week 1 to week 11 sessions?
So the thing is, certainly we have conducted all the sessions. So if you want to watch the maths like all week 1 to week 11 session, you can actually go to YouTube. So if you go to YouTube, this IITM online degree program, so there is a channel. Okay, so if you go to the playlist of that channel, actually you can get all the recordings of all the sessions of Maths 1. Okay.
Okay. Thank you.
Yeah, thanks.
Okay. If you have no further doubts, then we can close the session. I think we have Python session after this, right?
Okay, so then, yeah.
Yeah. Okay. Thank you, everyone. Yeah. Just go to the YouTube playlist. Okay.
Is it the? Can you share the PDFs that you have that has been displayed in the session?
Okay.
So Pius, what you have to do, you cannot directly, cannot paste the PDF, I guess. You have to create a link. You have to paste it in your drive, and then you have to paste the link. So you have to share that particularly.
Okay. I will do that. Okay, thank you. Yeah, I will share the PDF link. Yeah. Okay, thank you very much. Yeah.
Thank you. Thanks.
Hi, is there a class now? I see the class is being recorded into 19.